I feel the love. I feel the love. I hope it never goes away. I feel the love. Baby, what's your number? I wanna go under. Making you a memory, that's really all I need. I'm alive and breathing, living my best life. Love is on my mind and it's making me high. I'm staying in this moment, though it's hard sometimes, but I work it out every once in a while. I feel love. I feel love.
Good morning and welcome to day 3 of Apricot 2025. This morning you are in the network management and monitoring session, or not meant to be here. Go find the other room. Otherwise, we've got some great content for you. So this morning we have Dhruv Dodi, who will be presenting on next era of network management, or NEMOps. So Dhruv.
Good morning, everyone. I'll be talking about our workshop at IAB that we did, which was called NEMOps. So let's get to it. I hope you guys have heard of IAB, but if not, we are a body which provides long-term technical direction and work very closely with the rest of the ITF community as well as IRTF community. As you know, the work in ITF is usually done in working groups. Working groups are focused on very specific building block that they are developing. So sometimes we need to zoom out a little bit and talk of overall architectural oversight that we can provide. So that's what we do. And some of the times what we have to do is we like to run workshops specifically where we can have more focused discussion. Because usually what happens in ITF, the discussions are very much focused on protocol updates and the drafts updates and the documents, and we lose sight of the bigger picture. So sometimes having the experts in the room, fixing and talking about a problem for a little while longer helps us bring out things. So that's one of the things that we did with this workshop as well, which I'll be talking to you today. So this is not the first time IAB did a workshop on this topic. IAB and ITF community have been involved, and we do realize that we need to do more to get operator input directly in our process as well. So even in the past, we did like surveys, we reached out to the ops community like this. We went to NANOG, RIPE, and other places as well to try to get more feedback on what are the main issues that the operators are feeling when it comes to network management. And in June 2002, that was our big IAB workshop. This was a 3-day in-person workshop that happened. And this led to a lot of changes in ITF. It led to the model-driven way of doing things. We got Yang, we got a bunch of new protocols like NetConf, RESTConf. IoT came into picture that led to CoreConf and a lot of other things. Telemetry, all that work was sort of started with the IAB workshop. So that was a pretty good way for us to do that. But now 22 years have passed. We need to relook. Did we achieve what the operator wanted? Did some things work well? What did not work well? Are there some brand new requirements that were not the case back then? So this was our aim to go back and review our outcome of the past workshops. What are the current operational barriers that are still being felt? Are there some new requirements? Can we help ITF in a way by giving them some recommendations? As you know, IAB does not take part in the standard process directly. We are only here to provide some recommendation and action. Actual work has to happen in the ITF working groups anyway. Oh, before we jumped into the survey, we did an operator survey as well. We sent this to our Apricot and APNIC community as well, and some of you responded to our surveys. We went to Nanog, Ripe, and AutoConf and other operator-focused communities as well. And some of the interesting things that I'll put from that survey. Most popular configuration tool, people love CLI still, and they are still using it. There's a lot more Ansible now, so that's good. From the answers, it was also clear that people are using tools but may not be well aware of what's the protocol that's being used behind it, and that's make perfect sense. You are worried about operations. You're not so much worried about what's under the hood. But if you ask about protocols, people who are aware say like, yes, we are using a lot more netconf now. There is still SNMP. Even after this many years, that's still in use, and people are using. There is a lot more GNMI, RESTconf, these things as well. When you go to monitoring, that's where Prometheus is the most common. People love to make their own in-house tools as well. Some proprietary stuff, that's also in there. And SNMP for monitoring, still. What's missing is Yang. So use of Yang and RESTconf and netconf for monitoring, not at all. Another interesting output, kind of stuck. Thank you so much. Yes, most popular protocol for monitoring still SNMP. There's GNMI though, there's syslog. Some interesting data for us to look at. What are the most important tools? People are using Netbox, people are using Kafka, Puppet, Ansible, all of these stuff. We asked, are you considering network automation in your organization? Pretty good number says yes, that yes, network automation is in our pipelines. We need to think about it. To what extent it's already there, that's where you get like, yeah, not so much, but yes, it's something in our pipeline. Similarly, telemetry, there is a pretty, around half of our respondents said, yes, we are using streaming telemetry. We consider we can't rely on pole-based mechanisms anymore. So that's good. So this was just giving us an idea of where the operator community is at. And this immediately led to us also realize there's a huge disconnect within the ITF when we are so much focused on just producing a lot more Yang models, working on netconf and RESTconf and coreconf extensions one after the other. But we need to relook at why we are not seeing the deployment of some of these technologies that we have developed over time, and what is the main barrier, and can we do something different now rather than going on the same train and each working group still providing these outputs. So we got around 20 position papers, which were very good. All of them material is available online. The recordings of the workshops is also available online. So if you're interested and want to look at it, we have a workshop report, which is an internet draft at this stage. Go and read that. So all the materials that we have is available online. As workshop chairs, we decided to break these things down into 3 days of looking at the past, which is where are we coming from, what worked, what was the output of the workshop, are the requirements that were collected back then still true, what's happening. Then we looked at the present, what are the current problems, what are some new requirements, and some totally new ways of doing things. Where is the future direction that we could go to? This leads to a lot more discussion, not so much on the protocol parts, and there were some, but more about maybe the way ITF functions itself needs to change. The way we develop Yang models and network protocols, those set of recommendations also came out of this workshop. So I'll do that at the very last. We asked people to give us requirements, recommendation, potential next step. All of this is part of our workshop report as well. So let me start with some of the key points that I wanted to mention in the workshop. Jürgen, who was the author of the last workshop report, RFC 3535, this is the 2002 IAB workshop report, which collected a lot of requirements. And some of those requirements have stand the test of time, that yes, they are still valuable. In some cases, we realized that we delivered more than those requirements, because at that time, monitoring and telemetry was not on people's radar, but that's something that ITF has went ahead and delivered things on it. But where we faced problem, that was the main idea. So while we delivered things with a good way to configure network, but it was not done in a way that was clearly declarative, composable, reproducible, and verifiable. So these were the 4 key points for future direction that Jürgen gave us, which is amazing. Then we had an operator from Deutsche Telekom, which says that we are extensively using NetConf and Yang for all our stuff, but these are our challenges. We like it. We want you to make changes to this, but make sure that it is already being used. So don't make drastic changes that's going to break our stuff. So that was the message from them. They highlighted we have a huge issues with mapping models, that there are like service models, device models, models which are at the network level. How do we map things is difficult. There are multiple versions. There is open config. There is native models, IETF models. This whole good way for us to map things is very difficult. One other thing in this ecosystem is a problem is lack of open source. We don't have a very easy, good open source NMS that we can immediately go and download and start running. There is issue, and that led to a difference between what's documented in your internet drafts and RFCs versus what I can actually play with. And this has led to a lot of issues. So many operators and many folks in the workshop were saying that something needs to change. There needs to be enough focus on open source material of our network management protocols, that before we standardize, we need to make sure that there is some running code behind it. Otherwise, we'll face a lot more problems in actual deployment. Another look back from the past, we have Wes Hardiker, who was my co-chair for this workshop as well, who was the original author of NetSNMP. So he talked about how come this tool, like we all said that we have an issue with SNMP and SNMP doesn't do so many things, but how the simplicity of the tool led to its success, and how one of the first requirement that was identified in RFC 3535, which is ease of use, and we basically in IETF have kind of failed to deliver that. All our stuff is like, it's very feature rich. It does a lot of things, NetConf, RESTConf, Yang models, but it's not easy enough to use, and which we have to realize that, yes, we have failed to deliver this key requirements from the past. Another thing we had to look was when we were working in the past, IoT was not in the picture, but the network management of IoT is also a key requirements. And this is in fact a success story, that how we were able to use our existing Yang ecosystem, but develop it to support IoT as well. That's where CBOR, COAP, CoreConf, other things comes in, but it is very much aligned to the same model-driven network management principle that we worked on in the past. Rob Shakir, who's from Google and also the driver behind OpenConfig, was there. He told that especially mentioned that why there was a need to develop things in OpenConfig and why the IETF model was not working for them as a network operator. What they focused on, we need to iterate faster. The things need to be focused on systems and business outcomes and large-scale deployment, which is true. These are all very, very valid points from Rob. The discussion after these presentations were, the main issue with Yang models is we can't totally rely on them. There are some things we need to go back to CLI because this particular field I cannot access by Yang model. I need to only go to CLI and look at it. Some output I can only do if I can do screen scraping. So unless everything that I want from my network management system is available via Yang, I would have parallel systems in place, and that makes things very, very difficult. Everyone pointed out that IETF process remains a challenge for network management. Lack of tooling, same open source and tooling experience came in. Performance issues that okay, things works well when we are working with 100 of devices, but once we scale to a really large network, everything takes way, way longer. It's true. Learning curve, moving from CLI, the way our industry has always been certification based, the way I need to learn things, and moving it away from it has a lot of challenges. So this kind of transition from a different way of doing network management is something that we did not focus too much on. We focused directly on jumping to new models, new language, new way of things. But how do we make it easier for people to transition? That's something that we need to focus on as well. Challenges with backward compatibility, versioning, all the other things as well that was mentioned. So these are some of the points, feel free to check them out. Issue with, we would have multiple ways to look at, like we all use BMP, there is IPFix, there is this, but the key that I use to learn what is the node in IPv6 is very different than router ID in BMP, is very different from something that I'm going to use in netconf. So how do I harmonize this? Those things are somehow missing in a way in which we have done our network management. The second day, we focused on what are the monitoring. All of these were mostly operators. So we have operators from Swisscom. Their main focus was looking at Yang push. Telefonica, looking at new requirements. We had BT, again, talking about monitoring and making sure that what we configure, we are able to validate. Until there is this cycle, I'm not 100% sure that what netconf message I've given to the device, whether it's actually been configured or not, what is the problem. This kind of whole observability circle is something that was missing, and that's many operators focused on. Some of the highlights: transitioning is hard. What can be done to make mapping easily? There are vendor-specific implementation of both models and protocols, things that we deviate on. How do we do that? What is a good way for me to figure? If I'm an operator who has multiple vendors and vendors are deviating, what is the resource that I have that I can tap on? Is there a wiki? Is there some mapping that I can do? Those kind of things were highlighted by many operators. They know that we have to live with divergence in vendor implementation, but how do we make it easier for operators? Almost all vendors have native vendor models. We have our own CLI, sometimes those things exist, and there is no going away from it. But at the same time, if IETF has standard models, OpenConfig have standard models, how do we link them together? What is the way for us to easy map across them? And how to reduce the complexity of having multiple models in our system was something that was highlighted as well. Need for open source reference implementation, I think that's came in multiple times. Many examples were taken. For example, in IDR working group in IETF, we don't do BGP extensions until there are two interoperable implementation. Many folks said that we need to maybe start doing that for operations as well. And that's something that might be discussed in future in the IETF. Compliance and interoperability testing, we need some support. This is something beyond what IETF can do, but this is like looking at from our industry as well, like how can we help move towards model-driven architecture if we have a way for compliance and interoperability, easy enough to test. If there is an open source NMS across which I can check, oh, this new Yang model that is being proposed, is it working fine? Do we have enough good tooling to support it? Those were the things that were brought in during the workshop discussion. I talked about multiple models coexistence. And then another thing also to worry about is every network operations is kind of different. And in the sense that when OpenConfig came in, the kind of folks that were behind OpenConfig were very much focused on a very single-minded set. But in IETF, we have to deliver to a much more global set of network operations. So even a small network operator's requirement versus somebody at the scale of Google, all needs to be satisfied. So that discussion was very interesting, that how would we converge on these requirements quickly within an IETF model. The way we develop model, like for instance, BGP model has been going on for such a long time. It is still an internet draft, hasn't become an RFC. So those things were coming, and how can we make it faster? And because while we are working on the models, the features are also getting updated. How do we do these things together? On the final day, this was the future. Are we missing out on few things? Are you so focused on Yang and netconf and the current way of looking at the model? What's the future idea? So Benoit talked about knowledge graph, which was very interesting. This is something that is used in semantic web for resource description framework. And the idea of having an ontology for networking domain, very interesting. In fact, he has some running code that he has shown in IETF hackathon on this topic as well. So this is a totally different future direction worth thinking about, that some other industries are doing, but somehow missing in our network management paradigm. Kent gave a presentation looking at Maybe the issue is that there are so many protocols, there are so many different data representation mechanism. Can we put our focus on some key recommendation from ITF side? Something like maybe RESTconf is a better idea because we can easily use curl commands and do things much easier because of it's based on HTTP and rely on a lot of tools that are already available. So maybe focusing on RESTconf, maybe focusing on JSON, instead of doing the full Yang push, maybe Yang push Lite, NMDA, off-box data model, and protocol adopters. Actually, this off-box data model and protocol adopters was very interesting idea. The idea being, let the device do native device model, but we have tools which can easily map ITF or open config standard models into the device model of the box so that we can iterate faster. We don't have to recompile the device. We don't have to go and talk to the device things. Device can still be a native model, but we can still very easily map to an ITF model. This is a good idea. Let's see whether ITF can do something about this. Rob Wilton said that we need to focus on reducing complexity, providing more timely solution, open collaboration. So it should not be just like vendors working on a solution. We need inputs from operators early on. That's only when we will be able to deliver things. Otherwise, in 20 years' time, somebody else will come in from an IIB and say, oops, we haven't met all our requirements from network management operation. One interesting discussion was even in OpenConfig, we know they have been successful, they have been done, but they don't use NMDA. And there was a good discussion on why this particular technique is not used in GNMI and in OpenConfig model. And this was a very good debate between that. One issue when people say that, like, ITF needs to work faster, the one thing also is ITF works on consensus. So how do we balance the need for making sure there is consensus behind what we do, as well as deliver output quickly? So one option was discussed was maybe putting Yang models in an RFCs which cannot be changed is a wrong idea. And we should look at Yang models as source code rather than specification. And with source codes, there will be changes. You do get a stable reference, you get a stable version, but you can still iterate faster. Can we do something about it? So this is going to be something that needs to be discussed within the ITF as well. People said maybe because ITF gives so many options, there's netconf, restconf, coreconf, for doing the same thing, so many options, is that something that we should start avoiding? Should there be a single protocol? This was a little difficult to get an agreement on in the room because to converging on a single protocol is hard. We have known, we can go back to OSPF versus ISAS to know why it's difficult to converge on a single protocol. The off-box adapter, we did talk about it. Final was use of GitHub and thinking of a Yang model as code. And one thing we also realized is that during the discussion, I think based on people who were participating in the workshop, was more focused towards model-driven and more focused towards Yang and RESTconf. And many people were looking at what can be fixed within the system. But there is another approach that maybe more focus should be given in totally changing the way we have done things. That's something that we need to realize and recognize. And we are hoping that we will get more inputs from the operators on that as well. But main thing is, irrespective of what ITF does, there needs to be more better tooling, open source, and even who's going to support these activities. Is it going to be vendors? Is it going to be operators? Where is the ecosystem to support better network management operations? Who's putting the money behind it? That's very important. That's something that we did not cover in the workshop because it was a technical workshop, but this is something that we do need to recognize. We can talk about this, but to actually implement, it's where is the support coming from and which is the right community which can support it. These were at the end of the workshop. We said, okay, we did talk about multiple things. What are the things that we can all agree on? So we, as a workshop chairs, we wrote some things on a slide and said, do we all agree on this? This was a much longer list. Some people disagreed on it. Somehow the wordings got changed. So we did a bunch of live editing at the end of the workshop to somehow agree on something. So these were some of our key takeaways from ecosystem point of view. We all agreed that we have failed the operator top requirement of making things easy to use. So we have to start with that and recognize that that requirement we have largely failed on it. We all agreed that the ecosystem is extremely fragmented with both. There are a huge set of different protocols that people are using. There are polling-based, push-based, total different architecture that is being used. And that's going to be the reality of our network management for a while. That's not going to change. So we have to live with this fragmented ecosystem, but at the same time, think about how we can make things better. Lot more focus on documentation. Like IETF does standards, but that's not enough. What is the ecosystem by which we can have better documentation of how to use network management ecosystem? Because when we write a draft, or internet draft, we are very much focused on this is the protocol enhancement, this is the model, but how does all of this come together? That's something that maybe IETF doesn't do well. But what is the right ecosystem in which we can write this documentation? And even folks from the open config world and outside the IETF did realize that this is the gap that exists in our industry, and we need to do things around it. Focus again that the transitioning is going to be hard. It's one of the challenging things. We have faced this in the past from IPv4 to IPv6, and I think we are still facing this. Moving from CLI-based or SNMP-based system to a YANG-based model-driven system is going to be hard. So we need to make it easier for folks to transition. The people who are using NetConf and YANG, some of them are happy with it. And they said that, yes, the things that we used to do in the back were much more difficult. It did satisfy some of our requirements. So whatever you do, don't break the system, because at least the people who are using it, that it's working for them. Sorry. And the final one was like we need better tooling, which we all sort of agreed on. Protocol. From protocol point of view, we said that our current set of monitoring and modeling for monitoring, while support is there, it's not being used. So if it's not being used, what is the next things that we need to do to make it, make that change happen? Many people said that the full coverage is a big issue, that I want to get everything out of my NetConf and YANG model, and until I have a full coverage, I would not move to it. And then, irrespective of how IETF would wish, polling-based solutions are still deployed. They are still being used, and they still might be used in future. But we need to make it easier for people as telemetry and other things comes in. Modeling conclusions. YANG models can become too complex. Our protocols are complex. The number of features out there are complex. Number of knobs that we provide in our systems is complex. So yes, this is the reality. Can agree on it. Multi-vendor compatibility support is required. This is big. This is where we kind of discussed on, do we focus more on interoperability reports when we are publishing things? How do we make sure it? Should we maintain some kind of wiki at each working group level so that we make it easier for folks to say that, yes, give them more confidence in deploying our model-driven system. Point number 3, vendor-specific features. How do we make it easier? That's going to be there irrespective of how much we standardize things. These deviations are bound to exist. How do we make it easier for folks to still expose things which are proprietary to them, but still rely on a standard way of exposing them? So that's how we would put it. Service level modeling, like so far our focus has been very much on the device, but looking at services. L3 VPN service has been there, L2 VPN is there, but at the same time, service model modeling. And in fact, one thing also we realized is YANG is not just used by IETF, it's there at IEEE, it's there at BBF, it's there in other systems as well. So we need to continue to support at IETF the YANG, but still make it easier for people to more deploy. Configuration needs to be verified. That's something that we need to agree on. Standardization conclusion. I think this was the one that we debated kind of the most upon. We want rapid model development, but at the same time, how do we agree on consensus while we do things in the faster? So at IETF, we do worry about, like, if we say that we are going to do things faster, then at the same time, we know operators are busy. The people who are verifying things are busy. So if you do faster, you are also going to lose getting a much broader consensus on things. So what is the right balance that we will do? Who would have control? Usually at ITF, we do working group last call, then we do ITF last call, then it goes through the whole process. Then there is RFC editors who look at consistency of the models, who look at bigger. So we have this whole process. If we say we want to do faster, what are the things that we are ready to sacrifice? What are the things that we are, since we have, if we think of a Yang model as a source code, and since source code has versioning, and we think of it as bug fixing, then do we need to worry about it as much as we have done in the past? Because once the model is published, we are not going to change it. So is it a need to change our mindset a little bit when it comes to model? And what we can do model versus what we can do in protocol? Because many people did say that even to us to agree on what are the most important set of features, with Yang push as an example, to deliver, maybe we had wrong set of requirements to begin with. And we went in a mode that we need to support all these big features, while what was needed to deploy is a very small set initially. So having this versioning of what is the most minimal viable product that we need to deliver in a protocol versus a wish list of features that we want to do. So those kind of discussions are something that the ops community in the ITF needs to focus on as well. More standardization focus need to be given on scalability. So it's not just enough that the feature works, but can it scale? And how much time it takes for me to get information out of my devices as well as this. And more real world operator inputs rather than things from labs, things from this thing, that's very much important in the standardization part. So I'm coming towards the end. So this was a pretty good discussion on 3 days. Very active. We had each day we were having 3 hours of discussion, then a lot more on mailing list. On this, it was very, very intense, good conversation. But these are all just conversations. Our aim was having a more focused, in-depth discussion, and that's what workshops are for, but they are not the actual output. They can't lead to anything. So workshops, we say, is not the final destination. That's why I'm here talking about it, because this work needs to happen now. And there is a home in ITF, which is a working group called Network Management Operations. And they are, in fact, tasked with looking at what are the next set of operations requirement that needs to change. They are working on things like, some things that they have identified is, how does Yang, NetConf, and work with external tools like Kafka? How can we make this easier? So that work they have already started. Similarly, from this workshop, what are the key things from tooling, support from open source, these working group has already started working on. So if you have ideas, if you care about things, this is the working group where I will point you to. Come and participate, look at their output. A lot of operators are already there. Like, in fact, the chairs and folks are quite active. So I suggest looking at this further. We have the workshop report. The program committee had worked on workshop report. Basically, what I went through in today's slide is on the workshop report, that these are the things that got discussed. This is the things that we have agreement on. And there is a new document also in NMOPS working group that is covering brand new requirements for network operations and comparing it to what was published in RFC 3535 as well. So that's very interesting. A lot of these discussions will happen in the ITF meeting, which is in March in Bangkok. If for those who are from the region and around, if you want to attend the ITF meeting, please come and participate. Remote participation is also available, which might be easier because of the time zones as well. Again, a note that if the fee for remote participation is issued, there is no question asked, fee waivers for remote participation. Go and apply. Feel free to join, especially this working group if network monitoring is important to you. Some other cases is NetConf working group has their NetMod does a lot more Yang. So there are various network management things. Talk to me later on if you are interested in ITF activities and participate. One thing that we do is also realize that ITF participation is not just like, you need to write a draft and this thing. Just being an observer, understanding what is happening, and just providing your comments like how we do it on our operators mailing list. Oh, this operation requirements makes no sense to me. I will never do this in my deployment. That statement is valid. So just don't worry of ITF as it's going to take over your life. You could be as involved as you want to be, but we want you to be aware of what's happening in the ITF because it's going to impact your network operations, if not now, in few years down the line. And with that, I will end my presentation. Sorry for going a little over. Thank you.
Okay. Do we have any questions for Dhruv? Give a second for online. Nope. Okay. Thanks, Dhruv.
Thank
That
you.
was a really good recap of the workshop. So thanks so much for presenting.
Thank you.
If you have any questions for Dhruv, you can find him around the conference. Thank you very much.
Thank you.
Okay, so next up in this session, we have Tim Raphael. He's a IP automation PLM from Nokia, and he'll be presenting on network testing and making ops consistent. Just for this session also, it is just 2 presenters, but we do have just longer run times for each of them. Thanks.
Thank you, Mark. Right, hello everyone. As Mark introduced me, I'm a product line manager at Nokia for our automation suite of products. I cover the WAN and data center, so if you have any questions, come and find me later. But today I'm talking about network testing, how we can think about software testing methodologies and apply that to the network. So some questions that I'll be asking and answering today. Firstly, what is testing? What are the different types of testing in software engineering? And how does testing apply to network design and operations? And lastly, how can we actually test the network? So, first, what is testing? As engineers, a testing process to us is largely very intuitive. We're used to looking at a problem, thinking about our possible solutions, and trying different things to see if we can fix an issue. IBM's definition of testing is, the process of evaluating and verifying that a software product or application does what it's supposed to. As network engineers, we're largely curious. We'll look at a problem and say, okay, why is my BGP not coming up? There are certain inputs and there are certain outputs. So for any sort of testing of any system, you're providing known inputs and then testing for a given output. So systems in terms of software can be simple. I press a button and an object is returned to me. Or they could be really complex. Provide a large amount of complex data into the system and it forms a behavior or gives you something back. The challenge is when these software systems are complex. Like the tree on the slide, they have a lot of branching logic. You want to test a system in its entirety, you need to check every possible branch. Testing coverage is about ensuring that all of those branches are covered, but in reality, it's not feasible. So you have to think about a good enough process. So when you find a bug in software, bug is where your testing fails. So when you provide some inputs and an unexpected output occurs. When you find a bug in a piece of software, you can't be sure how many other bugs are in that piece of software until you find them. So you have to keep testing and then decide when you have a level of good enough. Sort of the paradigm of software testing. Often, you just have to think about the things that you care about the most and focus your effort on those. So, from the theory of testing, let's look at some different types. Unit testing, where we decompose a complex system down into nice small components and test them in isolation as best we can. Take a small component of the system, provide an input, test the output. Want to remove as many dependencies on the rest of the system so that you can just test a very small behavior. Because the theory is, test all of the small components of a system individually, when you put them together, the system should act predictably because all the components have been tested. So an example is if you have a config generator, you give it some JSON input and it returns a BGP configuration stanza. Known input, known output. So you might just test BGP, or you might just test the host name, or test the domain name of your configuration generator as an example. When the system is complex, you might need to use something called stubbing or mocking to take a component of that system that talks to the rest of the system and pretend that it's the rest of the system. Think about a vending machine and you tap your card to pay. If you were testing that vending machine, it would be fairly expensive for, 100 tests paying $2 for a can of Coke. So what you should do is stub the credit card mechanism such that it always says, yep, valid credit card. So then your vending machine logic, you can test in isolation, regardless of whether the card succeeds or not. And then we have system testing. This is often referred to as integration testing, and this aims to test the system as a whole from end to end. So often referred to as end-to-end testing as well. This ensures that all of our subunits work together. So you put in a larger, more complex input at one end, and you ensure that it flows through the system and gives you what you want. So in our configuration generator example, provide it the full input and ask for the full output and do a diff on what you expect it to be. And lastly, black box testing. While the previous two tests were mutually exclusive in their type, black box testing is worth talking about here because as network engineers and operators, this is what we're going to come across the most. You buy equipment from vendors and you don't have access to the source code. You don't have access to the logic tree. So you are looking at a black box. You provide it some input and something comes out. You don't have the opportunity to pull the system apart and just run the BGP daemon or just run the CLI daemon. So this type of functionality means that you have to step back from the system a little bit and think about the functionality that you care about and just test that. So then, how does testing apply to network design and operations? In terms of some typical network design use cases where testing can apply, think about migrating between vendors. You're going from network that's vendor A, where you run certain protocols with certain standards, and you're moving to vendor B. You might want to do some interoperability testing, where you have a known behavior that you're expecting with a given input, and you're expecting that same functionality to work on another vendor. So again, input, output. Say you're migrating between technologies. So currently SRv6 is the hot thing and people are moving from RSVP networks to SRv6. It is label switching. It is an underlay in a service provider network. And in reality, you want to test that you can achieve the same result just by changing the technology. Sometimes networks are designed to a specification. Say network architects could design a network to provide a customer service given certain SLAs. You need to make sure that if you change that design, you're going to meet those SLAs. There's also external specifications, so RFCs from ITF, IEEE, etc. That is a spec. That is your input. And lastly, something that some of the smaller operators are probably more familiar with is the iterative design approach, i.e. figure it out as we go. It's often build something, test it, change something, test it, make a change, test it. And by testing at each stage, you get the opportunity to see what changes. Have you improved the quality of service? Have you degraded it? And you can learn as you go. So let's map these to where this would sit with our types of testing. For the design validation stage, so this is pre-implementation, unit testing you could use to check that the inputs you give to a given protocol matches the RFC. Or if you're trying to hit a given goal in a network design iteration, you can define that goal ahead of time and test that that new design will meet your expectation. And then once we go into the implementation portion, you can then look at the systems and black box testing approach to ensure that one network does the same thing as the old network. So take a pre-state and test it after you've done a migration or a topology change. And then similarly moving between technology types. Say you're moving a customer overlay service from an RSV MPLS network to an SRv6 network. The customer still expects the same type of service. You can check that you're meeting that goal. So what about the operations end of things? Where can we use testing to help us operate consistently? Network baselining is a good place to start, and you'll see this in the demo later on in the presentation. As network engineers, we tend to have a feel for when things are right in the network. You walk in and you look at the graphs, it's like, yeah, okay, this is what I expect. Or, why is my intercap running a bit hot this morning? Why don't you codify that? Bring some structure, bring some certainty, and remove the human element and make it automatic. This allows you to capture the network state and compare it to what you expect. And it gives you very clear signals for when something's not quite right in the network or when you need to intervene and change. Software upgrades. In a lot of cases, these are very complex, higher risk processes where you might have a SOP or a MOP you've prepared ahead of time. And if you have an operator run through that MOP, yes, they could pull some CLI out and check it before and after, but again, codify it with a systems testing approach. Take the known good state, make a change, and then check and test exactly against that pre-state. And lastly, customer impact. I spoke about this before. If you are changing something about your network with the services you provide to customers, they have an expectation of end-to-end latency or jitter. You can do service level testing, IETF, Y1564, etc., to ensure that the end-to-end for the customer, the service level doesn't change. So, how do we test the network? We're going to get hands-on, and I'm going to use a video of a demo. Previously, I've done this talk where I've logged in and done it, and I found that, typing out CLI commands on stage is not as easy as I thought it would be. So you don't have to watch me fumble through the CLI, I've done a pre-recording. So what we're going to do is we're going to use NUTS. It's open source software that enables you to grab information from your network and run tests. So NUTS is a plugin for Python's excellent PyTest framework, which is used by a lot of open source tools. And it enables network-focused use cases by stitching Noneur and Napalm. So two very useful Python frameworks for talking to the network. There's some really well-documented examples, and you can even just write pure Python tests. So you don't have to use some of the built-in connectivity frameworks. You can just build it yourself, and you'll see some examples on the slides. So for NUTS, you define a test using the test classes. So they've provided some standard Napalm ones, and it's just a basic YAML syntax. So what we have here is the test, Napalm test interfaces, and then we provide some test data. This test data is your expectation. This is what you want to see from the network. So if the data that comes back from the network matches what you've defined in the test data, it's a test pass. And if it doesn't, it's a test fail. And as I've said before, Napalm is a very useful framework, and it means that there's a bunch of functionality straight out the box. So we can test interface parameters, ARP tables, BGP neighbors, LLDP neighbors, OSP neighbors, users VLANs, and you can even ping host to check end-to-end connectivity. So we're going to use a subset of those today. So when you run a test, or when you set this up, you provide a little bit of configuration to NUTS. That creates a test instance, which is the YAML file we just saw. NOR and Napalm then go and talk to the network, pull the state from the network, and does that comparison for you. Here are some example tests. I'll get into more of these in a bit as we get into the demo. So let's do some maintenance with a real world scenario. We have a 6-node leaf and spine topology. I'm using ContainerLab, which is an open source network lab software that Nokia supports. If you've not heard of ContainerLab yet, I highly suggest you go check it out at containerlab.dev. It supports not just Nokia network operating systems, but from a bunch of other vendors as well. We have a very helpful community on Discord as well. So have a look through the links and let us know if you've had fun with ContainerLab in the past. So we've got 6 nodes here, 2 super spines, and then a pod with 2 spines and 2 leaves. We're running Nokia's SR Linux platform in this case, and we have 100 gig, 32 port by 100 gig leaf and spines, and then a 64 port Tomahawk-based super spine. So this is fairly typical of what you would see in a real-world data center, and because we're using ContainerLab, the NOS doesn't know the difference. It thinks it's running on hardware. As for the protocols in this example, it's all a BGP fabric, so eBGP underlay between the private ASNs, and that's just to transport the loopbacks. And then we have an iBGP overlay for EVPN signaling. And on the right-hand side, you can see the super spines are acting as EVPN route reflectors. And between the leaves, we have a MAC VRF. That is just Nokia's terminology for a layer 2 EVPN domain. We have client 1 and client 2 connected to a port on each of the leaves. So we're going to go do some maintenance on the spine switches in this case. Because they don't talk EVPN, they're just layer 3 routers. So we can drain out a spine switch and the traffic will continue to run. So we can ensure that there's no impact to our clients. We're going to programmatically take a snapshot of the network state, build out a set of NUTS tests. And we'll use this test suite to go and do the maintenance, and you'll see through the process. So when we drain out the spine, the traffic will move around. This is just what we expect. So our pre-state script, I've cut off some of the more detailed methods, but it's not a lot of Python to connect to the devices, grab information about BGP neighbors, interfaces, and LLDP neighbors, and dynamically build our NUTS tests. Just the pre-state building script, this is effectively what it does. It goes and opens each devices, grabs BGP neighbors, reformats it into YAML. Grabs the interfaces, reformats it into YAML. Grabs the LLDP neighbors, reformats it into YAML. Because we end up generating over 300 tests just for this little 6-device network. To build out those test YAML files by hand would take quite a long time. Plus, by the time you've gone into the first device, pulled the state, by the time you get to the 6th device, something could have changed on the first device. And so we end up with a pre-state output that looks like this. Let's hop over to our demo video. So we're on a Ubuntu VM, and we're going to build our pre-state. So this runs our script and dumps it all out to a YAML file. And if we have a quick look, we can see we've generated a whole bunch of tests because every device has several BGP peers, at least 4 interfaces, and at least 4 LLDP neighbors. I think we end up with 308 tests in total. So you can see we've got the leaves, the spines, and the super spines included here. So for posterity, let's go and run our pre-state. So PyTest, and then we call the pre-state command. And nuts kicks in, collects our 300 odd tests, and in the space of 13-ish seconds, we've gone and tested that everything is good in the world. There's a few skip tests in there because we've not put the MAC address in for the interfaces, but that's okay. Everything is passed. So we have our pre-state. We should, there's a couple more tests we have as well. So I built some custom tests for EVPN, the bridge tables, and for something called maintenance groups. So to ensure that we don't affect our customers, we have a test that checks the number of MACs in the EVPN bridge table. So doing the same test with a little bit more verbosity there, you can see that we have 4 tests. So we check for the static EVPN MAC on each box, and then the learnt MAC from each of the leaves. We can also run the maintenance group test. So maintenance groups are a nice way to drain out a box with a BGP policy. What you don't want when you're finishing maintenance is to leave a maintenance group active. So we've got a test here to ensure that we don't leave a maintenance group active. So the test will fail if there is a maintenance group that is active, because that means BGP is drained. So we're going to hop into our spine 1, and we're going to just show you that we've got BGP neighbors running with, received, active, and transmitted routes. So you can see that we're receiving route, and we have 1 route active from each peer, which is just a loop back. It's what we expect. And having a look at the maintenance group here, you can see it's currently disabled. And that maintenance group will add a BGP policy to our underlay BGP group called drain BGP. So let's hop in and activate that group and start draining the traffic away from this node and prepare for maintenance. We've got a diff, and we're enabling policy. We have a look at our BGP peers. We now have 4 received routes, but no active, because we're draining the traffic away. So now we've got our spine isolated. And if we go and check our BGP peers for their policy, we can see that we have a reject all policy on each of our BGP peers. Great. Our maintenance group is doing what it should. Now we can go and do some maintenance. So say this was a software upgrade. Best practice is to generally shut down the interfaces facing the leaves, and then you can reboot the box. So we'll go and disable interface 1 and 2 here, and pretend to do some maintenance. So let's pretend we've rebooted the box and the software's come up. We can now go and enable our interfaces again and finish our maintenance. And we'll commit that change. So, in theory, we've done our maintenance. Oh yeah, let's go and undrain the BGP, of course, because yeah, we've done our maintenance. Undrain the BGP, disable the maintenance group, commit that, and we'll hop back to our tests. So, let's run those 2 custom tests to make sure that our EVPN bridge tables have the learnt routes in them, and that we don't have any active maintenance groups. Great, they pass. Job done, right? Well, let's go run our pre-state. That's what we captured at the beginning. Let's run our 308 different tests. In theory, we should be all good, should be all green. However, red is generally bad. So if we have a look here, what have we got? So BGP neighbor is not up. We're missing an LLDP neighbor. And it looks like it is enabled. It looks like there's an interface that's not enabled. Okay. Looks like I forgot to bring one of the interfaces up. But because we're running a leaf spine, our customer wasn't impacted. However, had I ended the maintenance here and gone and done the other spine, we would have dropped the customer traffic. So let's go in and fix this. And sure enough, I didn't bring interface 1 back up. Some of you may have caught that, wondered what I was doing. Right, that should be better. Is our interface up? Yep, good. Let's go and rerun our test again. The benefit here is in 12 seconds, I can test every interface that I care about in a network. It means maintenances are more efficient. If it's 2 a.m. in the morning and I make a mistake like this, I have tooling to help protect me and get it right. Let's hop back to the slides. So, let's review what we did. We built and ran our pre-state, and we had 308 different items. We had some custom tests. These, again, Nuts is just a plugin for PyTest. So you can drop to Python and run tests, and Nuts will run it. You can also create custom YAML to call custom napalm functions as well. So if you want to do extra processing or build your own classes, that's all possible as well. But in this case, you know, in half a dozen lines, I was able to add the maintenance group check. Had we finished our maintenance without undraining the device, this is what a failure would have looked like. Test maintenance group not active, and we have a failure. That tells you exactly which device you need to go and fix. And then on the EVPN services side, again, small number of lines of Python, and we can check to make sure our customer service that we're providing, which in reality is the thing we should care the most about. So we went in and we used SRL maintenance groups, and we enabled the group and added the BGP policies. This is a super useful little feature. And you can create multiple groups, you can have custom policies. Super, super useful. We inspected our underlay BGP neighbors and enabled the maintenance group and saw our traffic drain away. And you can see the reject policy that gets added by the maintenance group. So we went and did our maintenance and undrained. So we shut the interfaces to the box, did the maintenance, you know, software upgrade or a hardware swap, or, you know, some configuration testing or some load testing. There's plenty of different type of things you do in this scenario. Load the device back up with the maintenance group still active, enable the interfaces, bring back the maintenance group. And in this case, I tested for the maintenance groups being deactivated, and the EVPN bridge table had the max in it that we expect. We ran our pre-state and had a failure. So this managed to save us from what could have been a customer impacting outage. Because had we moved over to Spine 2 and done the same thing, we would have not had that redundant path, and the customer would have been on the phone pretty quick. So the diagram helps. I couldn't swap between the slides and the video in time, so this sort of helps. We had passing tests, but we had a failure. So test coverage is important. Just because you have some tests passing doesn't mean you're covering everything you need to be. So this is where you start to think about the service you provide the customer and all the dependencies. And that's where you need to test. It's like a complex system. You can't know everything, but you need to think about the things you care about. So when you're designing service constructs, when you're designing your maintenance procedures, it is very useful to codify these type of scenarios, because then you can avoid them in the future. Testing is also very useful when you think about it iteratively. Say you do maintenance and something doesn't go quite right. You have an unexpected failure or an unexpected issue with your configuration. Build a test to check for it next time. Rather than making your mop or your SOP another page longer, just add it to the testing script. And then every engineer that does this maintenance in the future can gain the benefit of the learning. And of course, we fixed the issue and reran the tests, and it all came back green, which is exactly what we want. So, the takeaways. Testing methodology isn't just about software development. You can apply the same principles to any sort of complex system. And networks, in my opinion, are some of the most interesting complex systems. You can apply testing to not just the operational end of things, but to the design process. If you want to add some structure to how you build or test or iterate on your network design, adding tests to ensure that you're meeting business goals and design goals and service goals are really helpful to guide you along that process. As I just mentioned, they improve the operational process. A failure by one team can then iterate into the improvement of the next time you do a maintenance, and it just gets better and more reliable. You catch problems before they occur, and especially before they impact customers. And you can improve your design process. Think about new ways of doing things and test them. Thank you very much. I'd appreciate any questions.
Any questions for Tim? Okay, we're good online.
Good.
Tim, I probably have a quick question for you.
Shoot.
So I liked some of the ASCII, green, red bars that were coming up there. And that's probably really good for the engineers to know that the testing's, been successful and completed. I guess you could also plumb all those testing into some sort of, I don't know, dashboard, Grafana, something like that as well.
Yep, absolutely. So PyTest is one of those industry standard testing frameworks used by hundreds, if not thousands, of large open source platforms. So if you were doing network changes through a CI/CD process, you can build this type of testing into the Git hooks and push and deploy type pipelines. So take the pre-state of the network before you apply a change, test it, take the output, perform the change, and then test it again. And if that test fails, you could even have the pipeline roll back the change.
Cool. All right.
Awesome.
Thank you, Tim.
Thank you.
That's the end of this session for today. So the next session in this room will be at 11:30. Thanks.